Hi everybody, we're back to lecture 38. In this lecture we're gonna, in the previous lecture really we talked about finding the centroid of composite area. Now we're gonna use or we're gonna develop similar methods for finding centroid of composite lines and composite volumes as well. Very similar to what we did in the previous lecture. And we'll also, touch the surface of finding the center of gravity as well. So let's get started. So like I said, the outcome is going to be having the method for finding the centroid of composite area, composite line, and composite volume. But we'll also look at center of gravity for non-homogeneous composite bodies. So what's a non-homogeneous composite body? It's a body that is composed of sections with different densities or different specific weight for that matter. And it comes handy quite many times. For example, here is one example from, again, from my research. I've been working on this problem of finite element simulation of a piglet brain. So this is a finite element simulation of the brain of a baby pig. And we can assume that more or less each section of it, say the green section, the brown section, the yellow section, each one has a different density. So we can think of it as a composite body, that each part of it has a different density, and we're dealing with a non-homogeneous composite body. We had to apply different loads on this brain, but really we also had to have the gravity being applied on it. So we had to find the center of gravity for this non-homogeneous composite body. So this is one example of how this can be handy, but again, we're not going to do this example for this class, and we're going to put our focus on this dam problem that we discussed previously. In this case, if we decide that it's made of, each part of the dam is made of different material, then we know that we're dealing with a non-homogeneous composite body. All right. So, really the take-home message from this slide is that everything that we did in the past for composite area, with the same logic, we can do the same thing for composite line and composite volume. So we can develop similar equations, similar sets of equations. It's just that for composite area we have A, for composite line we have L, and for composite volume we have V. And that's about it really. However, for center of gravity, there is something a little bit different. This is the first time for non-homogeneous composite bodies, this is the first time that density, or specific weight for that matter, will come to play. So the equations are going to depend on specific weight of each subsection, of each section that you have taken for the composite body. That's why we have gamma here. So if you look at the previous slide, we don't have gamma in this equation, right? We don't have gamma here. But here we do. This is the gamma. So that's why for finding the center of gravity this time, we need to have a knowledge of a specific weight of each part. So really for center of gravity, we can say that it depends on the weight of each part, whereas for centroid, it depends on the volume of each part. So really, if you're dividing, like before, if you're dividing a composite body into subsections, and you're planning to find the center of gravity and you know that this is a non-homogeneous composite body, then you have to do your sectioning really by paying attention to the density in each part and see if the section that you have chosen has one density or not. Because if it has more than one density, then you have to do more sectioning. All right, so that being said, we can generalize everything that we have said so far into this table for finding centroid or the center of mass for composite bodies. It's going to depend on your decision again, whether to assume the problem to be a composite line or composite area or composite volume, or maybe you're dealing with center of mass. So that's something that you have to decide about it, and of course which columns you're going to need here, right? But eventually you know how to use a table like this, and this table goes with the set of equations that you can see on the next slide. So like I said, this is the table you have to use, and these are the set of equations that would go with it. And this whole package is for finding the centroid and center of mass for composite bodies. Now, very similar to this, we can come up with a table, a very generic form of a table for computing center of gravity for a composite body. And again, this is going to be your decision how to use, what parameters you use in this table, right? And this table again goes with this set of equations for finding the center of gravity. And as you can see, there is gamma in all of these sets of equations, and in the table as well you have gamma. Of course you have one column for gamma, but then it's going to be multiplied in everything else here. So in this table you do have gamma. In the previous table you did not have gamma, right? So this is one table. It goes with this set of equations. This is the next table for center of gravity. It goes with this set of equations. That's basically the gist of the story for this session, right? And what's the problem-solving technique? It's again very similar to what we did in the past for the previous lecture. We had those 9 steps for problem solving. It's pretty similar to that, with the difference that this time you will start with seeing the bigger picture by deciding first of all whether you need centroid or center of mass or center of gravity, and then deciding whether you're dealing with a line composite or area composite or volume composite, and based on that you will choose the correct table and the correct set of equations from these slides, these 2 sets of slides, okay? And that's pretty much it. All right, so the last thing is that I want to suggest you to watch this really interesting video. Watch the minute 27 of this video. This is the name of the video and this is the link. And this professor is going to tell you a little bit about finding the center of mass in designing and how that can be useful in designing a rocket. So yeah, if you have an outer space trip coming up soon, I definitely suggest you to watch this video. All right, I hope you enjoy it, and I'll see you in class. Thank you.